Hello everyone, I am Parikshith V of class SHS3D of Aravind International Residential School. I am very thankful to my science teacher Chethan Abbur sir for giving me an opportunity to do this video. Today I am going to summarize physics chapter called Magnetic Effect of Electric Current. Magnetic field. The region surrounding a magnet in which the force of the magnet can be experienced is called magnetic field. Magnetic field lines. The lines along which the iron filings align themselves are called magnetic field lines. Properties of magnetic lines of force. A magnetic field lines originate from north pole and end at its south pole. A magnetic field line is a closed and continuous curve. The magnetic field lines are closer near the poles of a magnet where the magnetic field is strong and further apart where the magnetic field is weak. The magnetic field lines never intersect at each other. A uniform magnetic field is represented by parallel and equidistant field lines. Why are the magnetic field lines closed curves? The direction of the field lines is from its south pole to its north pole. So the magnetic field lines are closed curves. Why do not two magnetic lines of force intersect each other? If two magnetic lines of force intersect, then there will be two tangents and hence two directions of magnetic field at the point of intersection. This is not possible. How does the degree of closeness of the field lines represent? The degree of closeness of the field lines gives a measure of the strength of the magnetic field. Sources of magnetic field. Magnetic field due to a bar magnet. Magnetic field due to current carrying conductor. Magnetic field due to current carrying circular loop. How does the magnitude of the magnetic field produced by straight current carrying conductor vary? The magnitude of the magnetic field produced at a given point is directly proportional to the current passing through the wire, inversely proportional to the distance of the point from the wire. What changes in the deflection of the compass needle placed at a point near current carrying straight conductor is observed if current through conductor is increased. The deflection of compass needle increases because of the increase in the strength of the magnetic field. And second one, the direction of current in the conductor is reversed. The direction of deflection of the compass needle is reversed because the direction of magnetic field is reversed. And third one, compass is moved away from the conductor. The deflection of the compass needle decreases because of the decrease in the strength of the magnetic field. Right hand thumb rule. Imagine that you are holding a current carrying straight conductor in your right hand such that the thumb points towards the direction of current, then the fingers that wrap around the conductor in the direction of the field lines of the magnetic field. A current through a horizontal power line flows in the direction of east to west. What is the direction of magnetic field at the point directly below it and at a point directly above it? The current is in the east-west direction. Applying right hand thumb rule, we get the magnetic field at any point below or above the wire turns clockwise in a plane perpendicular to wire. When viewed from the east end and the anti-clockwise when viewed from the west end. Factors on which magnetic field produced by current carrying circular coil vary. The magnetic field produced at the center of circular coil carrying current depends on it inversely proportional to the radius of the coil, it directly proportional to the number of turns of the coil, it directly proportional to the strength of the current passing through the coil. Solenoid. A coil of many circular turns of insulated copper wire wrapped closely in the shape of cylinder is called solenoid. Factors on which magnetic field produced by current carrying solenoid depend. Number of turns of the solenoid. The larger the number of turns in the solenoid, stronger is the magnetic field produced. Strength of the current. The larger the current passed through the solenoid, stronger is the magnetic field produced. Nature of the core material. By winding the coil over a soft iron cylinder, the magnetic field can be increased several times. Use of solenoid. A solenoid can be used to produce uniform magnetic field in a given region. Electromagnet. An electromagnet is a device in which soft iron core placed inside a solenoid behaves as a powerful magnet when a current is passed through the solenoid. Fleming left hand rule. Stretch the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular. If the first finger points in the direction of magnetic field and the second finger in the direction of current, then the thumb will point in the direction of motion or the force acting on the conductor. Electric motor. An electric motor is a rotating device which converts electric energy into mechanical energy. Principle of electric motor. An electric motor works on the principle that a current carrying conductor placed in a magnetic field experiences a force. Construction of DC motor. An DC motor consists of an insulated copper coil of many turns wounded over a soft iron core. In the figure, ABCD represents the insulated coil. The coil is placed between the pole pieces of a concave cylindrical magnet. The free ends of the copper wire are connected to half rings of copper. Two carbon brushes touch the rings. The brushes are connected to the battery. Some devices in which electric motors are used: water pumps, electric fans, electric mixers, washing machines. Parts of electric motor and function. Field magnet. It is a strong horseshoe type magnet with concave poles. Parts of electric motor and function. Armature. It is a rectangular coil having a large number of turns of thin insulated copper wire wounded over a soft iron core. Split ring commutator. It is a cylindrical metal ring split into two halves. Brushes. It is made of graphite. It maintains a sliding contact with split rings. Role of split ring in an electric motor. The function of split ring commutator is to reverse the direction of current in the coil after every half rotation. Factors which increase the speed of rotation of coil in a motor. The speed of rotation of armature coil can be increased by increasing the strength of the magnetic field, the number of turns in the coil, the current in the coil. When is the force experienced by a current carrying conductor placed in a magnetic field largest or maximum? When direction of current is at right angle to the direction of magnetic field, then the force experienced by the conductor is maximum. When is the force experienced by a current carrying conductor is placed in a magnetic field? Minimum. When the current carrying conductor is held parallel to the direction of magnetic field, the force exerted on it is maximum or zero. Electromagnetic induction. The phenomenon by which the electric current is generated by changing the magnetic field lines is called electromagnetic induction. Cause of electromagnetic induction. Relative motion between the magnet and the coil is responsible for the generation of electric current in the coil. Galvanometer and its use. Galvanometer is a device used to measure the electric current flowing through a conductor. Fleming's right hand rule. Stretch the thumb, forefinger and middle finger of right hand so that they are perpendicular to each other. If the forefinger indicates the direction of magnetic field and the thumb shows the direction of motion of conductor, the middle finger will show the direction of induced current. Electric generator or dynamo. A generator is a device used to convert mechanical energy into electrical energy. Principle of electric generator. Electric generator works on the principle of electromagnetic induction. Construction of AC generator. An AC generator consists of an insulated copper coil of many turns wound over a soft iron core. In the figure, ABCD represent the insulated coil. The coil is placed between the pole pieces of concave cylindrical magnet. The free ends of the copper wire are connected to rings R1 and R2 of copper. Two carbon brushes touch the rings. The brushes are connected to battery. Working of AC generator. When the coil is made to rotate in clockwise direction, the magnetic field linked with the coil changes. This induces an electric current in the coil ABCD. During the second half of the rotation, current is induced in the coil along DC, BA, R2, B2, B1. During the first half of the rotation, the current flows along ABCD, R1, B1, B2. Alternating current. If the current changes its direction after equal interval of time is called alternating current. Frequency of alternating current. The frequency of alternating current is the number of times the direction of electric current changes in 1 second. In India, the frequency of AC is 50 Hz. Direct current. A current in which the magnitude and the direction do not change with time is called direct current. Sources of direct current. Sources of direct current are cell, DC generator, etc. DC generator. A generator which produces unidirectional current is called DC generator. AC versus DC. AC generator. The two ends of the coil are connected to full rings of a copper. DC generator. The two ends of the coil are connected to a commutator consisting of two half rings of copper. AC generator. The direction of current produced changes every half revolution. DC generator. The direction of current produced is same in both revolutions. Generator versus motor. Generator. It converts mechanical energy to electric current. Motor. It converts electric energy to mechanical energy. Generator. The coil is rotated in an electric field by an external force. It induces an electric current of the coil of the motor. Motor. Current is supplied to coil resulting in the rotation of the coil of the motor. Domestic electric circuits. What type of electricity is supplied to your house? Or for the electricity supplied to your houses, write the type of current, the voltage supplied, frequency of current supplied. Alternating current 220 volts and 50 Hz. Live wire. The wire which is a 220 volt potential is called live wire. Neutral wire. The wire which is at 0 volt potential is called neutral wire. Earth wire. The wire which is connected to a plate deep in the earth near the house is called earth wire. Color coding for electric wires used in domestic circuits. Live wire positive red, neutral wire negative black, earth wire green. Why do we use power supply of two different current rating at our homes? Different appliances have different power rating. The 5 ampere current rating is used for electric bulbs, fan, etc. The 15 ampere current rating is used for heater, geysers, air conditioners and iron box, etc. Earthing. The earth wire which has insulation of green color is usually connected to a metal plate deep in the earth near the house. What is the function of an earth wire? Why it is necessary to earth the metallic appliances? Earthing of an electric appliances means connecting the metallic body of high powered appliances to the earth through the earth wire of the domestic circuit. This prevents any electric shock to the user. That is why earthing of the electric appliances is necessary. Why are the appliances connected parallel to each other? In order that each appliance has equal potential difference, They are connected parallel to each other. Electric fuse. Electric fuse consists of a piece of wire made of metal or an alloy of appropriate melting point, for example, aluminium, copper, iron, lead, etc. Principle of electric fuse. Joule heating that takes place in the fuse melts it to break the electric circuit. Electric fuse. If a current larger than the specified value flows through the circuit, the temperature of fuse wire increases. This melts the fuse wire and breaks the circuit. Overloading. It occurs when the insulation of wires is damaged or there is a fault in the appliance. Overloading can also occur due to an accidental hike in the supply voltage. Short circuiting. Short circuiting occurs when the live wire and the neutral wire come in the direct contact. Thank you.